number 21, it says, on Friday you left for a weekend camping trip with 110 miles on the odometer with 14.5 gallons of gas in the tank of your car. When you returned on Sunday, the odometer read 299 miles and you still had 7.5 gallons of gas left. What was the fuel efficiency of your car on this trip? So I thought of it as you kind of like the X would be the gas. That would be the independent variable because like gas kind of depend on how far you're gonna get. So and then the miles would be the dependent variable. And so I just did the slope formula to find. So I did 299 minus 110 and 7.5 minus 14.5, and I got negative or 189 over -7, and that turned into negative 27. I got negative 27 because that's how much like gas you lost, or like how much miles per gallon you lost, I guess, and that's how I got 27 miles per gallon.
So the answer is going to be negative because as you're driving, you're losing fuel. So that's why you have a negative answer there. However, when you're talking about miles per gallon and fuel efficiency, we always say that it is 27 miles per gallon.
And for number 22, the problem reads, when you started your shift at 7 o'clock a.m., 120 steel valves had already been machined and were ready for assembly. At 3 o'clock p.m., your shift ended, and 424 steel valves were now completed and ready for assembly. The target production rate is 36 steel valves per hour. What was the production rate of your shift? Would your supervisor be satisfied with the work pace? So, when he came in, alright, so time would be the independent variable, and the steel valves would be the dependent variable. So when he came in, I just said 0 hours because he just came into work, he didn't work at all, and 120 steel valves had already been made. And when he ended his shift 8 hours later, 424 steel valves were produced. And I did the formula for slope, and I got 424 minus 120, and 8 minus 0, which is 38 valves per hour, and I said yes, the supervisor would be satisfied.
Nice explanation. Nice job, Chris. Thanks for your first one.
Thank you.
I'll keep that if you don't mind, so I have recognition. Nice job. Yeah, very nice, Chris. How bad was it standing up front, Chris? How horrible was it standing up front? Wasn't too bad. Thank you. Any questions on either of the problems Chris did? He did a nice job. No? Good. So remember, you're going to do 2 of those each semester, so Chris is done for the whole semester. I usually put them in as a group. I'll probably wait till like the end of the month in September and start entering them in. And then the 9-week mark is kind of like at the end of October. So at that point, if you don't have yours done, I'll just put a missing in. I won't put a 0. They're not due until the end of the first semester. But that's kind of just like a reminder, hey, you didn't do 1 after 9 weeks of school. So I'll put it in there as like a missing assignment, but it doesn't go into a 0 unless you don't have it complete by the end of the semester. So 2 by the end of the semester. And I have 2 of them, actually 3 different ones up there today. The first 2 have already been taken, so the second 2 I'll ask at the end of the class, and they kind of go together because it's kind of like a part 1, part 2. I'm going to collect that worksheet from you, but prior to me doing that, are there any other questions that you had on slope that you wanted to go over from the worksheet? Anybody need a stapler that I can pass around for you? Remember, I don't need the actual worksheet, I just need your paper. You can just pass that. Give it to Steven and we'll get that passed around as well. Make sure you place your name at the top. Give me a smiley face if you thought it was easy, a neutral face if you thought, it was alright, a frowny face if you were totally confused. Yes, yeah, you can just put it right there. You can just staple together. Make sure your name's on the board. Again, I don't need the worksheet unless you have something on that worksheet that I need to look at. Otherwise, I just need a piece of paper where your work is. Anybody else need the stapler? There should be 2 of them going around. You'll pass then the worksheet forward or your work forward, your homework forward. Sure, yep. So today we are going to talk about graphing lines. So we've talked about functions in section 2.1 and evaluating a function. Section 2.2 is slope. 2.3 would be graphing lines in slope-intercept form or by using x and y intercepts. And then tomorrow we're going to talk about writing equations of lines. We'll kind of wrap that up on Thursday, and then you'll have a quiz on Friday. So kind of just working through this review material on linear functions. In your notes packet, it's section 2.3. Second part of this chapter it is a little more interesting than the first part. So the second part, we'll talk about piecewise functions. We'll talk about something called linear regression. We'll go over graphing absolute value functions. We'll spend a little more time on that compared to the first half. But a chapter test is not too far off. I don't think it's next Friday, but it might be like the Monday after that. So we are going to graph linear equations today, which was the first graph that you would have learned to graph. As it says, slope-intercept or standard form, which means we're going to be finding the x and the y intercepts. Does anybody know what a parent function is? We're going to learn parent functions for every single graph we look at. Nick, what's a parent function?
Like the basic function.
Yeah. So each function has a parent function, and it's the most basic form of that function. It'll go through the origin every single time. It'll have a coefficient of 1 in front of its variable. So that makes it the most basic function. So it doesn't change the curve of the graph or the steepness of the line, and it always goes through the origin at 0, 0. So the most basic, we'll look at that most basic function, and then we'll build from that function. So for a line, just as a little refresher, here's our line. The parent function of a line is just y equals x. Because there's not a y-intercept, there's not a slope other than 1. So that makes it really basic. And as you can see, here's the graph here. So we have the y-intercept at 0. Also the x-intercept is right there. And then it says the slope is 1 because that's the number in front. And then underneath it says, in general, a y-intercept of a graph is the y-coordinate of the point where the graph intersects the y-axis. So wherever the graph is intersecting the y-axis, we call that a y-intercept. We'll talk about an x-intercept as well, being where it crosses the x-axis. So there are a couple of little tiny steps underneath. Just graphing a line in slope-intercept form. Talked about slope-intercept form a little bit already. What is slope-intercept form? Peter, what's slope-intercept form? Yeah, y equals mx plus b. And Peter, the m represents slope and the b is? Right. So the slope, remember, we said was rise over run. We use an M, think about the movement of the line, that's the slope. And the B is that y-intercept. And that's where the graph begins. So we plot that point first, you move with the slope. So if we're graphing in slope-intercept form, the first step is to write the equation in slope-intercept form by solving for y. You might not always have it in y equals mx plus b form. We might need to rearrange it a little bit. So write the equation in slope-intercept form. By solving the equation for y. The second step, it says blank the y-intercept b and use it to plot the point 0, b. So we will find the y-intercept, locate the y-intercept, whatever word you want to use there. Identify the y-intercept. Since they use identify in the next one. Step 3, identify the slope m. And use it to plot a second point on the line, and usually a third or a fourth so that we can kind of see the pattern. Bless you. And then the last one, of course, we'll draw that line through the 2 points, the 3 points, depending on how many we have. That kind of depends on how big your graph is as well. So we're going to graph an equation in slope-intercept form. And we have the equation y equals negative 3 halves x plus 1. I don't know what my little extra line is there. Hopefully you don't have a little extra line. That line shouldn't be there. Yeah, so ignore my little extra line. So graph this in slope-intercept form. Begin with b. So identify, find, locate the y-intercept. That's where you're starting. And that's this guy right here. Where does the y-intercept get plotted? Nina? On the y-axis. Which one's the y-axis? Yeah, the vertical one. Y is vertical. So we're going up to the value of 1 on the y-axis. And then you move with the slope. Our slope is negative 3 over 2. That negative needs to be assigned to one of those values, not both. I generally assign it to the top so that I'm going down 3, but then to the right 2. Only one of those is positive, the other one is negative. And then again, I can go a couple more down 3 and to the right 2. If I had space to go the opposite direction, I could place the negative underneath and move up 3, but backwards 2. And if you're moving backwards, that also represents a negative slope. Questions? So you begin with B, you move with the slope. The second concept we're going to look at, so like one little example there for you to kind of remember how to graph a slope-intercept, is called the standard form of a line. So slope-intercept is when you have a y equals mx plus b. Does anybody know what the standard form of a line is? Josh? Yeah. In most of the equations we look at, we'll talk about 2 different forms for each equation. So there'll be a standard form and what we call an easily graphed form. So it's easily graphed when it's an equal y equals mx plus b. But then we have this other standard form for every single function that we look at. So the x-intercept would be where the graph crosses the x-axis. Standard form can enable us to quickly find x and y intercepts. So an x-intercept is where the graph crosses the x-axis. The ordered pair would be x, comma, 0. standard form is useful to get x and y intercepts because generally they're pretty easy to solve for. So when we're graphing using standard form, the first one says to write the equation in standard form if needed. Generally, if it's in standard form, we're going to find an x, y intercept. If it's easy to get y by itself and get the y equals mx plus b form, then we would do that. So kind of it's like, what are you starting with? And then that's kind of the approach we would take to graph it. So it says identify the x-intercept by letting y equal 0 and solving for x. So if we're finding an x-intercept, it's when the y is equal to 0. So if we take this equation and let y become 0, then we should easily be able to get x by itself. Use the x-intercept to plot the point where the line crosses the x-axis. So anytime we find an x-intercept, y is always 0. It doesn't matter what type of equation we look at. So an x-intercept is found when the y is 0. The second step, identify the y-intercept now by letting the x become 0. Because now it's on the y-axis, that vertical axis, and the x value is 0. And of course solving for y. So essentially you're doing the opposite to find that other variable. Use the y-intercept to plot the point where the graph crosses the y-axis. And then finally draw a line through the 2 points. So in this case we will have 2 points. We should have one on the x-axis and one on the y-axis. So if you look at the equation, this is in standard form. We have 2x plus 3y equals 12. I'm going to make myself a little chart. It's not a T-chart, but just a little chart, one for the x-intercept, the other one for the y-intercept. So I'm going to have these 2 points. So an x-intercept is found when we let the y equal 0. A y-intercept is found when we let the x equal 0. I need to see a little bit of work. So a little bit. I gotta see work every single time, even if it's basic work, I need to see how you're getting these numbers. So to find the x-intercept, we're taking the equation, plugging a 0 in for y. I need to see that step. Michael, if we plug a 0 in for y, what happens with this term right here? Yeah, so that term goes away and we end up with 2x equals 12. So by plugging a 0 in, it cancels out the y term. And literally we have x that's almost by itself. So x is 6, but we need to write it as an intercept. Because we're not solving for x, we're trying to find the point that's located on the x-axis. Please make sure that if you're finding an intercept, you're writing it as a point. So I have that point at 6, 0. So on the x-axis, moving over to 6 and placing a point. We will stress proper notation throughout the year. If it's not properly notated, you will lose points. So the second one, the y-intercept is the same thing, except you're now plugging in a 0 for x. Which means this goes away. I divide by 3, and I get y equal to 4. So my ordered pair, because it's an intercept where it crosses the y-axis, is 0, 4. And then connect your 2 dots. So again, we could have graph that in y equals mx plus b form, but it's already in standard form. And it's really easy to find an x and a y-intercept and graph it that way as well. Questions? So if you flip to the last page of the section, it talks about horizontal and vertical lines. So while we can have lines that increase and decrease, meaning our slope is positive if it increases, it's negative if it decreases, we can also have lines that are just horizontal or vertical. So a horizontal line, it says the graph of y equals c is a horizontal line. And when you have a horizontal line, I came up with the acronym POI. The 0 represents the slope. And then the y says my horizontal line should be in y equals 4. For some reason, no matter what level of math, people get these two mixed up. And you're thinking, yeah, but I'm an honor student, why would I do that? It happens. I've taught for 17 years. So people forget that horizontal should be a horizontal line in the form of y equals. It'll pass through the point of something that goes through the y-axis. So I should have some kind of point here. It says the graph of y equals c, so I'm going to have the point at 0, c. So a horizontal line is y equals crossing through the y-axis at that value. A vertical line, we use the word vux, which I guess technically isn't a word, but this means that the slope is undefined. And that's what we talked about on Friday. An undefined slope creates a vertical line. That vertical line is in the form x equals instead of y equals. So horizontal line has a slope of 0, y equals 4. Vertical line has a slope that's undefined, and it's x equals 4. So if you look at the two graphs below, to graph the horizontal line, because it says y, you're going down to the y value of -1, and that's the only point that we would plot, and then you draw a horizontal line through that point. Maybe yours looks a little straighter than mine. Mine's pretty wiggly line. X equals means it's a vertical line going through the value of 2. So I would have a 2 on the x-axis. So this point would be at 2, 0. The point over here would be at 0, -1. And then it should be a vertical line. A vertical line never has a y-intercept. A horizontal line will never have an x-intercept unless it would actually be on that axis, that x equals 0 or y equals 0. Questions? So I have a worksheet. You guys have about 15 minutes. A lot of you packed up early on Friday. You're not packing up early in my class. Work until the bell. So use this time in an honors class. This doesn't happen very often, and I can tell you probably 95% of the days it will not happen, but use the time that you're given. So this worksheet has graphs provided on it. If you don't like the graphs because they are too small, I like graphing on larger graphs. There are multiple options of graph paper over there next to Stephen by the red bulletin board. So look at it. If you'd rather have a larger graph, then I can give you different graph paper. Again, I ask that you do this on a separate piece of paper. Nick already The first 6 are really basic. You have to identify the slope and the y-intercept, so that means get it in y equals 1. So you should see the work for getting y by itself. The second group of problems wants the x and the y-intercept. So again, I should see work. If you want to use the little chart, x-intercept on one side, y-intercept on the other. And then the last group of problems are graphing. Try and graph it if it's already given in like that standard form. Try and use the standard form to graph. I think there's 2 word problems on the back, 2 sets. So work with somebody if you'd like, but again, please do not pack up early. Use this time so that you get a lot of this done. Yes, sir. Yes. So you can do the graphing problems on this page. The work goes on a separate page. If you prefer a bigger piece of graph, Jack is right here where we have wonderful graph paper, different options. So there's this graph paper here that gives you a larger grid. It's still numbered, each axis is numbered, but up to you whichever graph paper you'd like to use.